I am going to be talking about mobile web performance. The deck is available for everyone right now. It is at estelle.github.com/mobileperf. All my talks are up at my GitHub account. My name's Estelle. I'm a female engineer. There aren't too many people in the world named Estelle. I think I'm the only engineer named Estelle. Not sure. How many Daves do we have in the room? Okay, yeah, exactly. So there are a few notes on the slide deck. If you are following along, if you press the number 4, you can take notes in the deck. And as long as you open it in the same browser and click on 4, I'm using local storage so you can save those. Again, the link. People are come in late, so if someone's sitting next to you, that's the link. Please tell them what it is. So let's get started. We're talking about phones, mobile devices, tablets, but mostly this is going to impact people who are accessing it on the phone much more than accessing your browser via GPS device or tablet. But this is relevant to all of those things. Topics we're going to be discussing is battery life. Who here has their phone tethered to a source right now? Okay, as many people as named Dave in this room. Okay. How many people have Windows phones? More people have Windows phones than are tethered. Okay, so you kind of see that being tethered during the day is not very common. So I kind of view the mobile device battery as the device on your right, rather the battery on your right, and your computer battery, the one on the left. When you're plugged in, you're not really thinking about your battery. When you're driving around in your car, you're not really thinking about your battery. When you're using a flashlight, you turn it off to go from room to room. People on their mobile devices are not turning off their batteries when they go from room to room or app to app, and they're not thinking about their battery. You, as a developer, are responsible for thinking about their battery because your web applications are going to drain their battery, and they're not expecting that. So what drains people's battery? There's this great article that came out in, I guess it was in April at the conference in Lyon, France. And it's all about battery usage. And basically, it's too long didn't read? Who here has heard about that article? This article right here. No, okay. I would have thought more people would have. So let me summarize it for you, because it is definitely a too long didn't read. But what they did is they attached mobile devices to a thing that's, I have no clue what it's called, but it's a device that checks how much electrical consumption there is. And then they tested a bunch of different websites, and they looked at the battery consumption of just loading the page, and then caching those pages, and just executing, just parsing the JavaScript. Yeah?
The author is speaking tomorrow.
The author is speaking tomorrow. Who is it? I could look at it. Angela Nikaora?
Yes.
Okay. So definitely go hear her talk. I don't even know what she's talking about, but this article is awesome. So definitely go to that. And I don't need to summarize it that well for you since you guys are going to go to the talk. But basically what they did is they looked at what was using up battery power. Was it the CSS? Was it the JavaScript? Was it the images? Was it the text? Was it all of the above? And what they discovered is that JPEGs sometimes perform better than GIFs and PNGs, that images do use energy, and something that you probably already knew, which is that energy used to render images is basically relative to how many images are on the page and what their size is. So what that means is if you're sending an image this big to a mobile device, you're not just over the airwaves using up too much space, but the phone has no use for it, and you're using up battery usage. But the main thing is JavaScript. And this was surprising to find to me that CSS also consumes battery. We all knew that images used up battery power, right? But who thought that jQuery, sending jQuery to your phone would use up battery power? You probably didn't think about it much. A few people, I can't see a thing with this light in my eyes. You probably, when it came to jQuery, you knew that putting it down over the airwaves was going to be an issue, but it actually takes 4 joules of energy to parse jQuery. So when you're doing a mobile site, you've been using jQuery your entire life because IE6, IE7, IE8, and IE9 suck, right? But mobile devices have really good, powerful browsers, and they support a lot of the ECMAScript that isn't supported in IE8. Things like jQuery, things like query selector all, query selector, get element by class name. So sometimes people are downloading this jQuery, like in the case of Wikipedia, they're downloading jQuery to do a get element by ID, which by default, get element by ID is supported on every single browser since probably Netscape 4.7 or earlier. I know that my first framework back in 2003, I had to do get element by document.layers instead of get element by ID because browsers back then didn't support it, but it's been supported since 2002, 2003. Why are we including these external libraries? So those are a few things you need to think about. I'm not saying don't use a JavaScript framework, and actually JavaScript frameworks are fabulous. They'll make your development cycle so much faster. All of these things that we're going to cover today are things that there's no right answer. There's no right answer. There's no wrong answer. These are just basically pitfalls that you need to consider when developing a mobile web app. So yeah, use JavaScript. Use it a lot, but don't use it for animation because it's going to suck. It's going to drain your battery like there's no tomorrow. Instead, use CSS animation. That's what CSS animation is there for. And don't import a library if you don't need to, because parsing it, even if you're not using it, uses up battery power. But this is an example of what I thought was a brilliant idea, using all native features. This is done with CSS gradients. So I thought, oh, this is so much better than putting a PNG over the airwaves. I didn't think about performance. This is actually now the website that I go to when I'm cold in a lecture hall. Like when I'm attending, I'm sitting in the back, I'm cold, I open up this page and I hug my computer because my computer warms up. Right? Imagine what is that would be doing to the battery on your mobile device. So what I'm saying is there's no right answer, but radial gradients, animating radial gradients and scaling them will completely use up battery power for a few reasons. One, every time, it's basically measuring. It's when a browser receives an image, like a PNG, it actually knows exactly what pixel goes where. When you're setting it CSS gradient, it's measuring what pixel color is where. And then I'm animating that. And there's transparency, so it has to figure out exactly, it has to measure every single pixel 60 times a second. And that's using up battery power. So what uses up battery? Reflowing and repainting. We've always been concerned with a reflowing page, and if you don't understand what reflow and repaint are, I'll get to it later. But it's actually reflows and repaints. Another trick to do is to minimize your JS and only use it when you really need it. Don't bring in a library just for one line of code. Use vanilla JS if you can. Use CSS animations instead of JavaScript animations. Things like WebGL, which is not really supported yet on mobile devices, but will be, that'll drain your battery. It drains my battery here. You know, if I open up a WebGL page with animation, has anyone seen the fish tank WebGL page that Google did? Absolutely awesome, but I actually, like, the reason I use the gradients, the page before, to warm me up is the WebGL makes the computer too hot and burns me. So use WebGL if, like, your electricity goes out and you want to warm up, like, the whole bedroom. Use this one if it's as a personal electric blanket. So implement everything you've learned today, and also avoid loading resources that you don't need. When you load JavaScript, again, frameworks, if you're not using them, your browser's still going to parse them. And also manage your memory, which we'll get to. So the next topic I want to go over was latency. And you've probably all know, like, the main thing that people talk about is latency when it comes to performance. That is on your desktop or on your mobile device. And we have some great rules. Steve right here was one of the original authors of Why Slow. And then he went to Google and changed the name to PageSpeed, right? No. He added a few features, too, that are really helpful. But what these two things, has everyone here heard of YSlow and page speed? Okay, so I won't go into what they are. But if you haven't, there's a link right here to download it. It is an extension for your browser. Definitely click on this link and install it. In Firefox, you first have to install Firebug for YSlow to work, but it's an extension of the other browsers. Same thing with Google Page Speed. Download it, install it, put it in your browser, use it. I'm not going to go over it because most people raise their hand, but if you don't have it, definitely use it. Also, another neat little trick is if you actually want to use this as a resource later on, it has all the rules in there. You can click on these things. Okay, so some of the rules are things like include CSS at the top and your scripts at the bottom. And this is brilliant because when your browser hits JavaScript, it stops parsing and it stops downloading and it stops rendering the page, and it thinks to itself, oh, this might be 1999. Some idiot might have put a document right in this JavaScript. And so basically it stops everything, downloads, parses, executes all your JavaScript before continuing. So you put the JavaScript at the bottom it doesn't make your page download faster, it just makes it seem like it downloads faster. So it's much better perceived download speed. And the thing is, this is all well and good. Those rules are great. This means that you're making your requests for your JavaScript at the end. But one of the things that we think of, this floor is like the squeakiest thing.
I'm just typing an email.
Yeah, okay. I'm going to stop moving. I'm just going to stand like this. So, or maybe even if I take my shoes off. Okay, so this is the way normal DNS works. And I think I stole this slide from Nicholas Zakis, but I'm not sure. So when you make an HTTP request, you're basically saying, where is velocity.conf.com? That's what you type into the address bar. And your computer's like, I have no clue what you just wrote, but let me go ask. And it goes to DNS server, comes back and says, oh, that's the IP address. Let me go ask it and get the site, right? The thing with mobile devices is you have increased latency because when you're not on Wi-Fi, when you're over your network, you're not asking, when you're making an HTTP request, you're not going directly to a DNS server. You're first going to the cell tower. From the cell tower, you're usually going to the phone company or whoever is providing your 3G service. And then it goes to the DNS server, which responds to the phone company, which responds to the cell tower, which responds to your mobile device. And then your mobile device is like, oh, I know what IP address you want now. And it makes the request again. This is right here. This is where all the latency occurs. So one of the things with mobile is that you want to reduce, whereas it's important with desktop when you're wired, it's vital when it comes to mobile devices, because that's actually where the biggest amount of slowdown comes. If you're looking at a waterfall of what's taking how much time, that's where you'll see the biggest amount of time spent is the latency of getting the files. So Steve Souders has this wonderful page. And I couldn't include it in my website. This is the extension on your page is .php, so I can't actually include it as an object, so I have to include the title page and then go to this, and I don't really know why. But he has this little bookmarklet. So right now I'm going to go into tools, and then I'm going to talk about latency again. But I wanted you to think about latency before going into the tools that I'm going to cover. So this is a tool right here, which is kind of like one of the things that's been really hard for us to do is to debug on mobile devices. We can't really see what the latency is on a mobile device because we're downloading the page here, right? And this has no tools. And this is making noise. So Steve Souders created this little bookmarklet, which you can include. And there's all the instructions right here. And basically, when you have it open in your mobile device, it has this little window, and it includes Firebug Lite, so you can debug with that. So this is a great little tool. But the tool that people are really using nowadays is Winery. And this is the instructions for installing Winery. Who here is a front-end engineer? Who here is a back-end engineer? Who here is not an engineer? Okay, we have a few. So I'm a front-end, and Winery comes down as a jar file, and I see Java, and I just go, ah. But when you install Node, you install npm, and it's so much easier to install Winery when you have Node.js. So I highly recommend installing Node.js. Who here has installed Node.js? Okay, so you already have npm, and all you have to do is this one-line command to install Winery. And I'm going to show you in a minute what Winery looks like. But if you want it, here is the full instructions. So you have 5 steps. If you want to, click on the number 4, and you can write, no, I was in the wrong spot on the page. Click on the number 4, and you can take notes here. Take notes. That's for the new people in the room. So just write a note to yourself that you better look at this. So Adobe came out with this thing called Adobe Shadow, and it's basically Winery on crack. And the way it works is it installs Winery, but Winery is a kind of a pain in the tushy because you have to install a little JS snippet. So this is what you install Adobe Shadow on your computer, and it installs this. And you just have to have that black little screen open, and that's all well and good. Then the other thing you do is you go here, and you say, hey, find my device. And then you go on your phone, and you also install, this is a high-tech presentation of a tiny little device. So way in the back there, I hope you can see this. But I'm not going to actually do anything on here, so I didn't want to waste time going back and forth between presentations. So HTC Desire, that's this phone. And you see that it's on Google right there. If I type in Standardista, this is a live presentation, so it's not going to work. And you see I didn't touch the phone. Okay, so that is Adobe Shadow. So who cares, right? If I open this, and I click on this right here, this little button up here, I get a web inspector. And then I can go to my console, and I can do alert. Hi. This is not going to work because it's a live presentation. And I know you can see in the back row, you can see this, right? It does say alert hi. I mean, there's alert on this, and it says hi. You see that? Okay, he can confirm that. So that is Winery. And I can actually go in here and just like the web inspector from on Google, or inspector from Firebug, or Dragonfly from Opera, I can use this as a development tool. So we were going to spend 5 minutes to install it, and seeing the number of people here and the few number of computers that are out, we are not going to go through that. But the steps are right there. I actually went through it. How does this connect to this and not to your phone? Right? Because you're like, wait, we're all on the same network. You do have to be on the same network for Winery to work. What I didn't spend the time showing you is that the device has a passcode, and I enter the passcode into my Adobe Shadow, so that way the two will communicate. That's the security, that's why it's secure. Okay, so that's Winery. Another tool that I use to see how long my website takes is WebWait. And this is the ugliest site. I hear they spend a lot of money on a graphic designer. I'm kidding. This is like the type of artwork that I do, and that is why I'm a developer and not a designer. But what I do is I open it. Oops. I open this page in my phone. I'm lost. Where are we? Right there. I open this page in my phone, and then I stick a website in here. Let's just do Standardista so you can see how poorly Standardista.com. But I do this from my phone. And then I say time it. If you saw there was a little box that opened down here, it's actually opening up the page and loading up the page 5 times in there. So the first time it might not be cached, but the second, third, fourth, and fifth time, it's just an iframe. And it times how long it's going to take to load. So the first time it took 6 seconds. So when I do it from my phone, I can see how long it's taking. It's kind of useful. I mean, there's so many better tools to do this from the desktop, but this is kind of like the cheap, hokey way that I do it on my phone because it's so quick and easy and dirty. So that is webwait.com. The link is right up here if you want to try it. So that brings us back to the issue of latency. So these are tools that I can use to see what issues my files are having. The other one is, of course, okay, I was supposed to show you that later. But this tool right here, click on network, it shows you the files. So those are the quick and dirty tools to use to test what your latency is. But how can we improve upon it? The things you want to do to improve latency is to reduce the number of requests that you're making. So the issue is requests take longer to complete over mobile, and the solution is reduce those requests. And I can read to you my slides so well. Okay, so this is what we had before, right? We put the CSS in the header and the JavaScript right before the closing body tag. And that's the best practices for desktop. But sometimes the best practices for mobile is this, where instead of doing the external file, we actually embed. And then we embed all the, we embed the style, sorry, and then we embed the script. And then we add one little script here, which is to take this script and this style outside of being embedded, save it into local storage, set some cookies, and the next time we access the web page, we send the cookies over, because every time you make an HTTP request, the cookies get sent along. So you have that overhead anyways, you might as well use it. And we tell the server, hey, I have this script file based on the ID, and I have, or rather style, the CSS, and I have this script based on this ID, send me what I don't have yet. And those two numbers right here, these are bings. This is m.bing.com. And so let me just go over here. This is m.bing.com. It sends over one huge image. Every day it changes. And then it has this. And the first time you load it, it's 226 kilobytes. That is one ginormous file. But it's one file, it's one HTTP request. The second time you load that exact same page, it's 19.56 kilobytes. That's a very small page, but it is just one HTTP request. So what have they done? What they've done is they have actually pulled out all of their JS and CSS and their images. Instead of doing what is the standard best practice of making them all, like separating the concerns. I mean, they have separated the concerns. The script is in script tags, but it's all in one file. So it's kind of like an anti-pattern. But what they did is they sent it in one long file. And let me actually show you the file. I have it open here. This, I believe, is the original file. And the reason I'm showing it to you this way is because on the right, you can see that it is a ginormous file. And I actually added the spaces in so that I could read it better, but it was all minified. So that is that's 226 kilobytes and in the middle of this somewhere, there's an orange line where there's the data URI. This is LinkedIn's right here. LinkedIn sends over, they do the same thing. And this is a data URI for the LinkedIn image on mobile. And I'm not sure LinkedIn does it quite right, because I think this is absolutely ridiculous. I think that might actually be deserving of an extra HTTP request. Someone said, maybe that's their database of passwords. I wish I had a t-shirt or a book to give out to you, because that was awesome. So I'm not sure LinkedIn is doing it correctly. So that's what I mean. Like, some people are like, well, what's the solution? I'm like, I can't give you the solution. But the solution is to think about it, realize what the issues are, and realize that these are your options, and test it yourself. And if it's like, 4 milliseconds difference, go for the easiest solution. But, if you're taking 12 seconds to download your mobile device, you need to figure out a different way to do things. So, back to the presentation, if we can find it. Is it there? Yeah. So what Bing did is they actually pulled out, you saw how big that file was, right? They pulled out, they gave something an ID of japp.home, and they pulled it out and they set it in their cookies. They set it in their local storage, rather. And then in their cookies, right there, they set a cookie, the RMSM cookie, japp home, JUX search box, JUX nav sliding. And for those of you who aren't colorblind, this is green, pink, and kind of bluish purple. And this is green, pink, and kind of bluish purple. So I color-coded those three so you could see that they were actually in there. And if you look in here, there's something like when web inspectors crash, but right now it's doing good. So let's hope it stays there. So resources, local storage. Here's Bing. Here's my local storage for Bing. That's a lot of local storage. Now, there are articles online about, like, local storage is really bad, it's really slow. It is slow, but it's faster in many cases than doing an HTTP request over mobile. So you don't want to necessarily do this for your desktop, because this might be slower when someone is tethered or when someone's on Wi-Fi. So again, you need to come to your own decisions. I can't tell you how to develop, but I can make you aware of certain things. So what the best practices are. Here, they embedded CSS, JavaScript, and their images as background images, as data URIs. They put them in local storage. They use cookies to get them, and then they sent the cookies back and forth like your browser does every single time it makes a request. And so then the server was like, hey, read the cookie. These are the things we don't have, and that's why this is at 19.56. Maybe that was a new image, or maybe that was just scripts, or maybe that was a search result. And then they use data URIs. And why is this orange? Oh, that's a note to myself to talk about data URIs. Data URIs are orange in my code deck because of this. This is a data URI. This is a data URI for a full-size image. LinkedIn decided to use data URIs because it's faster. You don't have to make an HTTP request. But they didn't optimize their image. So that's why this is what it looks like. Twitter does a really good usage of data URIs. Why would Twitter use data URIs instead of a sprite? Because they would need to know who your friends are. And they would need to have, like Twitter, I'm talking about the avatars. They know who your friends are, but they don't know off the cuff that someone is going to be retweeting someone else. So instead of sending 100 little images this big, the data URIs are probably under 1,000 characters. That is cheaper than doing an HTTP request. So again, figure out what you're doing and figure out for yourself what works best. So since this is a tutorial, I want to go a little bit into local storage because this, and I'm not going to actually have you guys do the code example. Just one second. Okay, I'm not going to actually have you guys do the code example, or maybe I will at the end if we have time, because not everyone has a computer and no one has a table. But this is how easy local storage is. Unlike cookies, there is actually an API for local storage. The API is very simple. You get local storage. Who here has now memorized that word and how to type it? Ooh, okay, that was really hard. We can add content with a set item. We set a key and a value pair. So local storage is a key value pair. If you saw in here, local storage right here, here's the key, here's the value. It even gives you that as heads of their columns. So there I have proven that. It gives you get item, and you just pass it the key. Remove item is delete a single entry. Clear is really dangerous. It clears everything for your entire domain name for local storage. So it's dangerous for me to, you don't want to be like, I hope no one clicked on this because all your notes would disappear. So don't click on that. And then it is basically, it's an object. So it inherits from the object. And we have things like length, stringify to JSON, everything else. If we have time, we can come back and do this code lab, but I don't think it makes the best use of our time to do it right now. Okay, so do you remember when I wrote you can take notes? Earlier in the presentation? Here, this is the code lab. This is the solution to that code lab. So basically, if you follow these instructions, right, you'll get a page that does this. So if you want to do this at home, the files are here, the solution's here. If we have time, we'll do this at the end. But I'm not going to, I'll let people go if they don't have computers before getting to it. And this is just an example of using those four methods and one property. Actually, I'm not clearing all. 4 objects in local storage. That was done with length. Getting items right here. You can set an item right here. Kittens. You always have to have kittens. And bacon in any presentation. Or else it's not really a technical presentation. So here's that. So if you want to learn how to do local storage, you already know. Who here has memorized the 4 methods? Okay, for those of you who haven't, repeat after me. Set item, get item, remove item, and clear. Okay, now who has memorized them? All right, we're doing good. We learned something today. Okay, so next topic is memory. Memory on your computer, when you are developing your mobile web applications, you're likely doing it on a device like this. Probably a prettier version, a less abused version, but probably actually with more memory because I haven't upgraded this to 8 gigs yet. It's still at 4 gigs because I'm going to actually upgrade it next week to 16 gigs. So you're developing on devices that have 8 gigs of RAM, right? 4 gigs of RAM? What does this have? This is actually my speediest mobile device and I have tons of mobile devices at home. It's at 768, less than a gig. So when I'm developing and my browser is kind of like heating up, the computer heats up. It's all well and good. It allocates memory. When the browser runs out of memory, because there's no more memory, the browser crashes. Bad user experience. So in addition to thinking about latency, and definitely it's your job to think about battery because, yeah, if your users are playing Angry Birds on their phone, they know that they're wasting their battery. Like, they know that. But if they're visiting mint.com or linkedin.com or Google or Wikipedia, like Wikipedia, how dynamic of a site is that? Wikipedia is draining the battery. The worst website out there, according to that paper, Apple. They're the ones who sell the most tablets in the world. I think 15 million every 3 months, so 60 million a year. That's a lot of devices. They don't actually have an optimized page. Their home page is not optimized for mobile. Crazy. Okay, so this is the devices that were in my home when they were actually the devices that were on my desktop when I wrote this slide. My iPhone 3G had 128. This is my HTC Inspire 768. I did this on my other MacBook, which has 8 gigs. My iPod Touch, I just got a new iPod Touch, so I need to check that one out. My iPad 1, 256. That's the memory I'm dealing with. That is not, let me move again, because this is driving me crazy. That is not the memory that I have for my browser. This is the memory that I have for my browser. This is actually done in, this is not a screenshot, because this was before I knew how to do screenshots with my phone. I'm kidding. I don't know why I didn't take a screenshot. But the important line is the one at the bottom. 73 megabytes available. This was the day that I bought my HTC Inspire. That was the default apps that were open that I had nothing to do with. It's not like your users who have Angry Birds running, and then now I have Adobe Shadow running. It's actually still running. So that's what you're dealing with. You're not dealing with the pretty 768 that you see here, which is definitely enough to run any website, hopefully. If not, you have a serious problem.